Okay, guys, we're going to talk about the GNSS lab, or the GPS lab, if you will, and what's expected of you, a couple tricks on how to do this so that it doesn't take you a whole lot of time. The reason why we've added this lab, or we have this lab, is because it's super common to get a series of different GPS data points collected by multiple teams that you then have to consolidate, work on, build your own file, bring that file based on GPS coordinates into the GIS. And there's a lot of ways things can go wrong. This is set up in a way that I don't think it's inherently obvious that you're going to have problems, but oftentimes you do, and that's some of the reason for this video as well as this lab, and we'll talk through some of the reasons why you might run into some issues. So the bottom line is this gives you an opportunity to build on some of the skills that you've done before. We're going to ask you to do a couple things. First of all, notice it's a 75-point lab. 2 crews were asked to go out and collect data in the West Point training area. So mine locations, gates, and position markers. So we're going to call them mines, gates, and markers. 2 crews went out. 1 crew had the task to get gates. The other crews went out and got mines and markers. So there's 2 different Excel tables where they entered their data. So I'll show you in the Y drive, there's the data's there in 2 different folders, and take note that the GPS data was collected in WGS84 decimal degree format. An interesting sidebar on decimal degree format. When somebody tells you they've collected data in WGS84 and it's in DD format, that would be decimal degrees. If they say DMS, that would be degree minute second. What's interesting about that is sometimes that data comes looking exactly the same. So for example, let's say it's 40 degrees 30 minutes, 30 seconds. Well, in degree minute second, that would be 40.30 for minutes, and then 30 for seconds, let's say. So 40 degrees, 30 minutes, 30 seconds would be 40.3030. That looks like a decimal degree, but if you plot 40.3030 as decimals degrees, that's not going to be the same thing as degrees minutes seconds. So you just need to know what type of file format or how they stored the data. There's not an easy way inside Excel to guarantee that it's degree minute seconds. So a lot of times what people do that are somewhat savvy is they're in their header associated with an X coordinate, Y coordinate. They'll put DMS if it's in degrees minute seconds, or they'll put DD to indicate it's in decimal degrees. In the second data folder, there's some shape files provided to you from the West Point data file, and this is what's in each of the 2 folders. So lakes, roads, and boundaries. The first step is to prepare the Excel sheets for GIS input. So we'll explore that. The first data set looks like this. It's always good to look at our attribute table. This is what the attribute table shows. So we've got our X coordinate, our Y coordinate, a height measurement, when the data was collected, and then the gate number. And then if we go to the second group, they didn't have near as much information. They simply have a description, M and mark. So M's going to be mines, mark's going to be markers, and then their X and their Y coordinates. Okay, fair enough. So how do we get all of this into one data set that makes sense? The way I look at it is I can sit here and I can cut and paste my X and my Y's here into the other folder underneath the X and Y's, and then I could just cut and paste the description down as well. But these descriptions don't really mean anything to me. If I want to symbolize based on my description, what I really want to do is I want to call this a marker and this a marker, and then just cut or copy that down for all the markers. And then for the same, but those were mines, not markers. See, you can make mistakes very easily. So you make these mines, and then you make these markers, and you want to make sure that you type them in exactly the same way. And now I can cut and paste all of this. To do that, what I have to do is I've got to go into my other crew, and I'm going to get rid of all of this stuff, as well as my feature ID. And then I'm going to get a consolidated set of data, and this is all of my data cut and paste. So the gates, I just called a gate a gate. I've got my coordinates, I've got an ID. As I scroll down, I've got 138 starting at 0, so I have 139 records. And this is all in one file. So I called that my group data, and I stored it in my working space. So I've got my data set up. There's a method to my madness on why I set it up that way. There's a lot of other ways you could do it if you wanted. So that's done. Step 2, create the base map and add my layers of data. Know that we want our data frame in state plane coordinate system. So what that's basically saying is I've got my data frame here, and in my map you right click, you go to properties, and we've talked about this before, but set it up as NAD83 state plane. We want New York 3101 East. So to find that, we've got to go into our projected folder for the coordinates, and I know it takes, you got to really scroll through this to find it. But when we get to the top of this, you know, it's NAD 1983 2001 U.S. survey feet inside the state plane projected coordinate systems, and you say OK. So I'm in a state plane coordinate system specific to New York, so we'll zoom in on New York. Just know that state plane coordinate systems are set up to be really accurate coordinate systems for the state or the particular portion of the state that we're dealing with. Small little things like a centimeter off here or there are big deals for certain processes and measurements for state surveyors. So they've got a really fine coordinate system set up that surveyors use. So I just wanted you to bring the data into state plane coordinate system. Again, I'm running on my background that I like, and we're going to load some data. We'll load our boundaries, our lake, and our roads from West Point. And even though that data is in a different coordinate system, because we specified its coordinate system and we specified the data frame's coordinate system, it talks and it lines up nicely. And we can color code and symbolize these the way we want to. The boundary might as well be hollow. And we'll leave the roads the way they are, it doesn't matter. So next we want to add data. We want to add our XY data, and to do that we just do, and you've done this in your PE in the past, but you're just going to do add XY point data, and it's going to give you an actual tool called the XY table to point. You're going to point to where you save that file. I put mine on the desktop, and it's my group data, and I saved it as an XLS file. If you double click on the folder initially, it gives you the table inside the Excel database, and that's what you want. Single click on that and say OK. When you do that, everything populates for you quickly. It's going to say, what do you want the feature class to be saved as? If you created a new project when you worked on this and you set your environments properly, you're going to have a geodatabase associated with this project, and it's going to store this inside that geodatabase. So we have a shape file that's going to be generated here, and it shows you exactly where. So you can change the name if you want. I'm just going to leave it standard because I don't care. It also knew that the x coordinate and the y coordinate were the fields x and y. It pulled that out on its own. So if you label your tables correctly or in a smart labeling convention, the computer is going to figure that out for you. It also assumed that we're in GCS, so that's Geographic Coordinate System, WGS84, and in this particular case it is. This is where it gets tricky. If this was in state plane coordinate, New York West data collect, we need to specify that. If we put the wrong coordinate system in here, the points will not line up or not go where we want it to go. And this is one of the things that I was saying oftentimes becomes a problem. So the default's correct in this particular instance, and we just hit run. And it shouldn't take too long, and the points will show up, and they do. And you can see them all right here. I can highlight the symbology, make these guys a little bit stand out a little bit better, and you can see all the points. We can explore the points by going into the attribute table of our feature class, by right-clicking and going in and exploring what the attribute table looks like. And you can see this feature ID column that I created actually just stays in there. It created its own object ID. So that row, or that record, correction, that field was not necessary. These three stayed. It knew that each one was a point, so it created a point, shape identifier, and then an object ID associated with each one. Notice the descriptions, gates, mines, and markers are also there. So very useful stuff. If I then want to symbolize these based on the attribute description, I can right-click on the layer, go to Symbology, and it's a little temperamental. I much prefer to do this with a mouse, and I'm doing it with a touch a finger. So we want to do this based on unique values. Description is correct, and this button right here says add all values. And when I add all values based on descriptions, you can see down here gates, markers, and mines, and you can see over here gate, markers, and mines. So that's how I want to symbolize those. And then I can go into each one, I can click on it, and I can change the symbology into whatever it is I might want to have. Alright, so we'll call it this casino marker, and a mine, we'll do the library symbol. But bottom line is you can see a bunch of symbols, unique symbols to each one. When you do a layout, you can create a legend, and you can make sure that you've got the right symbology associated with it. And we have now created unique symbols for each of these. So that's how we would do that, and that's why we build our attribute table and the consolidated list the way we do. A lot of tricks to that is the misspelling of markers and mines, or capitals here and not capitals here. When you hit get unique values, there'll be different ones. And that's why oftentimes if you send a bunch of GPS field crews out to collect data, you'll give them attribute domains, a data dictionary with attribute domains, that when they say store this GPS point, it's drop downs to say this is a gate, or this is a marker, or this is a mine, right? And it'll all be spelled the same way, either all caps, first letter capitalized, whatever. It's dummy proof. And then you, as the GIS analyst, aren't going in making those modifications all the time. Some other things to note. As I move the marker, my mouse around here, you can see down here at the bottom center of the table, you can see that I'm in XY coordinate US feet. Because I'm in the data frame of state plane coordinate system New York East 3101, that's the coordinates associated with the state plane New York East coordinate system. It's US feet. I've got my easting and my northing, and wherever I'm pointing this mouse, that's my grid coordinate. One of the tasks is to get a coordinate for a certain place at West Point. So I'm going to change my base map layer. I'm going to show you how you can do this quickly. I'm going to turn off my data that I generated. We're just going to zoom in using this imagery layer to show you how you can get a grid coordinate. So let's say that we had the task of getting the grid coordinate for Mikey Stadium, the center of the crest. And you can see how I move the mouse a little bit in the center of the screen, that the numbers change just a little bit. And these are feet. You can tell as I move around that's about right for feet. What if I wanted MGRS grid coordinate for that? Well, I can come here. I can say I want my military grid reference system coordinate, and I can move up here, and you can see this makes sense. 18 Tango, Whiskey Lima, 86607, right? And as I move around ever so slightly with my mouse, it's moving a little bit. So you can tell, you can make sense of what is a 10-digit grid coordinate and how much does each unit represent in a 10-digit grid coordinate, right? And then we can go back to, decimal degrees, or let's do degrees, minutes, seconds. It actually shows us the degree, minutes, seconds, and as I move this all over the place, I'm barely moving, right? See how much? All I'm really getting moving there is a second of a degree of latitude. So this is fun to play with. I'm going to ask you for U.S. survey feet of a certain spot in this lab. I'm not going to show you, I'm not going to give you that, but put your mouse there, get a screen capture with your mouse there, if you will. You can do the Alt print screen to get that, and then type up your answer that way. So let's look. Okay, so we inserted our collected points. I'm going to update this piece here. One of the things it says is to kind of clip the data to just the area we're looking at. We can do that. I may modify this, so just make sure you read section 4. One of the things we want you to do is add other layers of data. So find some other data. A place to get that is the New York State Clearinghouse. You can also find some data on the X, the Y, the Z drives. You can go to the Atlas, the Living Atlas, that you have seen or is available to you in your tutorial workbook. But I want you to get one from an online source and just highlight what that online source is in your write-up. Something like the New York State Clearinghouse or some other place, maybe USGS, get the topo map of West Point area, or whatever it is, wherever you want to get data. If you're a remote sensing guru and you want to download Digital Globe remote sensing imagery and bring it in, you can do that, or Landsat imagery, you can do that if you know how to get this. If you don't know, go to the New York State Clearinghouse data, figure out what the county is for West Point, and download some data to your hard drive, bring it into ArcGIS, and make sense of what data is out there and available to you free of charge from the state of New York. You've got listed here your deliverables, and I wish you guys the best of luck.